Lesson 65 has a title of Prime Factorization, Division by Primes, and Factor Trees. And we use division by primes and factor trees to help us prime factorize, or to find prime factorization. So the first question says, use division by primes to find the prime factorization of 36. Now what we want to do when we use division by primes is to make something called a division cake. And that division cake is going to start with 36 divided by the smallest prime number we can think of. Well, if we've got the smallest prime number that we can think of, 36 divided by 3, okay, because 3 is prime, is going to give us an answer of 12. Then if we take 12 and we divide it by the largest prime number that we can think of, that would again be 3. And 12 divided by 3 is 4. Then we take 4, we divide it by the largest prime number that we can think of, and we get 2. 4 divided by 2 is 2. Then we take 2, we divide it by the largest prime number we can think of, that's 2, and we know 2 divided by 2 is 1. We're done. We've got our division cake. It's a cake because the 1 is supposed to be like a candle on top. Now, our answer. Well, our answer for this is our divisors. So what we're going to do with our divisors is multiply them. So we're going to get 2 times 2 times 3 times 3. And when we multiply all these are all prime numbers. We're finding prime factorization. When we multiply all these prime numbers, we'll get the answer of what we originally started with. So if we did that to check, 2 times 2, that's 4. 3 times 3, that's 9. And 4 times 9 is 36. So we found the right prime factorization. This problem is done at this step when you say 2 times 2 times 3 times 3. You can check your work by doing this, and your product should be what you were originally finding. Another way that we can find prime factorization of a number is to use a factor tree. This question says, use a factor tree to find the prime factorization of 60. Use 4 and 15 as the first branches. Let's go ahead and do that. So if we have 60, we're going to find the prime factorization, so we want to know what prime numbers multiply to get us to 60. This says the first branches should be 4 and 15. Now, we've got to break 4 down into prime numbers. So, the next branch off of 4, in order to get to 4, we have to multiply 2 times 2. We're always multiplying the numbers below to get to the number above. 15. Well, that would be 3 times 5. And we're done, because all of the numbers we have here are prime. We've got 2, 2, 3, and 5. Remember, a prime number only has factors of 1 in itself. So if we wanted to check our answer, well, we could say 2 times 2 times 3 times 5. And when we multiply those, we should get 60. 2 times 2, that's 4. 3 times 5, that's 15. And if we have 4 times 15, yes, that must be equal to 60. So we got the answer right. We can go ahead and box it, and we can move on to our next question. Now before we move on to our next question, I want to show you that when we use a factor tree, it doesn't matter what our first branches are. This one says to use 4 and 15 as the first branches, but you might have thought, I can get to 60 by saying 10 times 6. Or maybe you said I can get to 60 by saying 20 times 3. It doesn't matter what you pick as your first branches. You'll always come to the same answer. Let's see that. 10. Well, 10, that's 2 times 5. And 6, that's 2 times 3. So what we see for our prime factorization is we have 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. And look, we've got exactly the same answers. Doesn't matter what your first branch is unless you're told specifically to use something as that first branch. You'll always come to the same answer. Lesson practice will be on page 349. Make sure you've got your notes complete, and I'll see you during our next class.